Okay, let's go over section 4.4, number 51. So this is an example of infinity minus infinity case for L'Hopital's rule. Right, so let's do that. All right, first thing, let's make sure that we really get infinity minus infinity. Right, so here, the first term, 1 over x. As x approaches 0 from the positive side, so 1 over 0 goes to infinity. And it's slightly positive, positive over positive, it's going to be positive infinity. So first term goes to positive infinity. All right, minus, let's look at this second term here. All right, so as x approaches 0 from the positive side, e to the 0 is 1, so you get 1 minus 1. And so that's 0 on the denominator, 1 on top, so it's going to go to, and x approaches 0 from the positive side, so you know that it's going to go to positive infinity. Alright, so this is hidden L'Hopital's rule problem. Right, so let's try to make it so that it looks like L'Hopital's rule problem. So we still have a limit as x approaches 0 from the positive side. Alright, so I'm going to just do take the common denominator. So common denominator is the easiest one to just multiply the denominators together. So it's going to be just x times e to the x minus 1. Alright, so we took the common denominator. So we have to multiply this 1 by e to the x minus 1. So it's going to be just e to the x minus 1. Right? Then you have a negative sign here, so you have to put a negative sign there. Then you have to multiply 1 by x. So it's going to be simply minus x. Alright, now you have a fraction, so it looks more like L'Hopital's rule. So let's see what happens. If you plug in 0, e to the 0 is 1. 1 minus 1 minus x is going to 0. So you can see that the numerator is approaching 0. Alright, the denominator is easy. 0 times e to the 0, 1 minus 1. So it's actually both of them goes to 0. So denominator is approaching 0. Alright, now we have a 0 over 0, so we can apply L'Hopital's rule. So let's go down here. So we're going to apply L'Hopital's rule here. Right, so we still have the limit, but we get to take the derivative of the numerator, which will give us, alright, derivative of e to the x is e to the x. And derivative of negative 1 is 0, so I'm not going to write anything down. Derivative of negative x is negative 1. So you have e to the x minus 1 on top. Right, derivative of that would be, so I'm going to use a product rule. So x is the first guy, so it's going to be 1 times the second guy, so it's going to be e to the x minus 1 plus, right, first guy, x. Then derivative of the second is derivative of e to the x is e to the x. Derivative of negative 1 is 0. So you just have e to the x. Alright, so clean it up a little bit. So you're going to have, let's see, I'll probably go here. Alright, let's clean up. So you have a limit still. X approaches 0 from the positive side. Alright, you have e to the x minus 1, so that looks nice already. Here we clean up and you have e to the x minus 1 plus x times e to the x. Right, so just clean up. Alright, let's see, let's plug in. Alright, so you can see that the e to the 0 is 1 minus 1, so the numerator still goes to 0. Alright, and the denominator would be e to the 0 is 1 minus 1 is 0. 0 times e to the 0 is going to be 0 too. So you can see that the denominator still goes to 0. Alright, So we can apply L'Hopital's rule again. So L'Hopital's rule, right? So you're going to have a limit, right, as x approaches 0 from the positive side, right? Derivative of e to the x is e to the x. Derivative of -1 is 0, so you just get e to the x, right? Derivative of e to the x is e to the x. Derivative of -1 is 0. Derivative of x times e to the x, I have to use product rule. So derivative of x is 1 times second e to the x plus first guy x times derivative of e to the x is e to the x. Alright, then we can plug in. So you can see that on top, if you plug in x equals 0, so you have e to the 0, right, which is 1. Then you have e to the 0 again, plus 1 times e to the 0 is e to the 0. And plus, alright, so it's going to be 0 times e to the 0 is going to be 0. So this guy is just simply 0. And all the e to the 0 is 1. So you're going to get e to the 0 is 1 over, you have 1 plus 1 and plus 0, which is 1/2. Right? So that's the limit. Right? That's it. I hope that this was clear.